Good morning, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about a problem in t-test, or test for hypothesis for the mean, using the critical value method. So I'll share my computer screen with you. It is estimated the average age of a tennis fan is 32. To test this claim, a researcher selected a simple random sample of 18 tennis fans and found the sample mean is equal to 31.3 years and sample standard deviation S is equal to 2.8 years. Assume the sample came from a normal population. At a level of significance of 0.05, can we conclude, should be there, that the average age of a tennis fan is less than 32? Let's change this a little bit. So at a significance level of 0.05 of 0.05 of 0.05 is the average age of a tennis fan less than 32. So let's get started on this. So first we write the null hypothesis or the status quo. Oops, I got to take care of that. So let me fill out this bag. That the average simple. Okay. So let's write our null hypothesis and our alternate hypothesis. So H sub 0, which is the status quo, is mu equal to 32. And we want to test whether the evidence from the sample shows that the alternate hypothesis, that we can support the alternate hypothesis which states the average age is less than 32. Less than 32. Notice the two slanted lines indicating less than meets at an age pointing to the left. This is a left-tailed test. Left-tailed test. What does it mean? Rejection of H0 region lies in the left tail. In the left tail. Okay. Here our sample size n is equal to 18. X bar is equal to 31.3. And S is equal to 2.8. Since sample size n is less than 30 and population standard deviation is not known, population standard deviation is not known, deviation is not known, we will use t-distribution. Use t-distribution to test the hypothesis. Test the hypothesis. So if I create a little bit more space, so DF, or degrees of freedom, for the t-distribution in this case, t-distribution in this case is df is equal to n minus 1. 18 minus 1 is 17. Also, we have been given alpha, level of significance. Is equal to 0.05, which is the maximum probability of rejecting H0 when it is true. Okay. Alpha is equal to the area of rejection. So we draw the T distribution. This is the T distribution for df is equal to 17 and our alpha is 0.05. That means at the center where the peak is the highest, T is equal to 0. This is a left tail test, so area of rejection is over here. This is your area of rejection. With alpha equal to 0.05. That is the area of rejection. Okay, now I need to find this minus T alpha. Okay, so what is minus T alpha? Is the critical value of T in the left tail of this T distribution. Why called critical? Why it is called critical value? Because we reject H0 to the left of it and to the right of it we do not reject. We do not reject H0. Now, wait a minute. Do not just leave. I'll give you a very important hint at the end. Okay. So we need to find this critical value of T alpha. The area to the left of it minus T alpha. The area to the left of it is equal to alpha. And we reject the null hypothesis on the left of it. Okay. And we do not reject the H0 on the right of it. So how to find this critical value minus T alpha for degrees of freedom 7T? So we will use TI-84 for this. Use TI-84. So stick with me till the end. I'll give you an important hint. Okay. So you press the second key, then the verse key on the third row of the calculator keys. And then scroll down to number 4, which is in T. Okay, so let's do that. Second verse, scroll down to number 4, which is in T. They're asking for area. And that area is 0.05. So type in 0.05. They're asking for degrees of freedom, which is already be calculated is 18 minus 1, type 17. And then go down to PEST whenever you are on PEST, let me get rid of that. Okay, so this is really dead. Okay, area is 0.05, DF is 0.70, is 17. Then PEST, put the cursor on PEST, and when you put your cursor on PEST, hit enter twice. Enter twice. Okay, so enter and enter. So you get an answer for minus T alpha. Minus T alpha is the critical value of T. Minus T alpha is minus 1.7396. This is important. Okay. Now, again, do not quit right now because I'll share with you an important hint at the end. Okay. So now we will calculate. So let me change the color of the game. Let us calculate a test statistic, which is a characteristic of the sample. Characteristic of the sample that we have collected, that we are working with. So the test statistic is follow the T distribution and is given by X bar minus mu sub 0 divided by S over square root of N. Here X bar is the sample mean. And let's go up and find out what is the sample mean that we started this problem with. Is 31.3 and S is 2.8. So X bar is the sample mean is equal to 31.3 and S is the sample standard deviation. Standard deviation is equal to 2.3. Okay, and let me make sure S is 2.3. I just want to make sure that S is 2.8 actually. And that was a mistake. So let's correct that. So S is 2.8. Okay. Now what is mu 0? Mu 0 is the hypothesized population mean. It is the value in the null hypothesis. Null hypothesis. Mu sub 0 is equal to 32. Okay. And N, I believe, was 18. Okay. Yeah. Okay. So let's calculate the test statistic T. Here I want to stress that S over N, square root of N, is the standard deviation of the sampling distribution of X bar. Sampling distribution of X bar. Of X bar. Okay. So, what is my S over square root of N? Is equal to 2.8 divided by, I'm using my calculator TI-84. So second button, X square button, which will give me the square root inside the square root 18 and enter. And that becomes equal to 2.8 divided by second button, and X square gives me the square root 18. And that is equal to 0.6599. 0.65996. Okay, so let me create some space. So my test statistic T is equal to X bar is 31.3 minus 32 divided by S over square root of N is 0.65996. So if I write in here my calculator, left parenthesis 31.3 minus 32, right parenthesis divided by 0.65996, I get the test statistic T as, so left parenthesis 31.3 minus 32, right parenthesis divided by 0.65996, and that is equal to minus 1.06. Okay, now let me remind you what was my critical value and everything. So remember, my critical value we determined is minus 1.7396. Okay, so if I just draw the picture again, the T distribution. So this is T is equal to 0. This is the T distribution. At the center where the peak is the highest, the mean is 0. Okay. And degrees of freedom in this case is 17. Each T distribution is associated with the degree of freedom. In this case, degrees of freedom is sample size minus 1. And the critical value as determined. So minus this. So this area, remember, is alpha. Area is alpha. This is the 0.05. And in the unshaded region, we do not reject H0. And in the shaded region, we reject H0. So my minus T alpha is minus 1.7396 or something. Okay. Now my test statistic is only minus 1.06. So if I change the color of the key. So I have calculated a test statistic which is very close to 0. So somewhere over here. So, and this T value, the test statistic is minus 1.06. So we can write, since T equal to test statistic T is, okay, value of minus 1.06 is greater than critical value T alpha of minus 1.73. Otherwise, that is T test statistic value of minus 1.06 falls inside the do not reject H0 region. Reject H0 region. Again, don't quit right now. I'm on the verge of sharing an important hint with you. Okay. The decision is, so the test statistic falls in the do not reject H0 region. Decision is at alpha is equal to 0.05. There is not enough evidence to support HA. Thus, do not reject H0. Do not reject H0 at alpha is equal to 0.05. And we showed by the critical value method that the critical value is less than the test statistic. That is, it is to the left of the test statistic. The test statistic itself falls in the do not reject H0 region. Hence, we do not reject H0. The hint is there is another way of doing this problem, which I will show in the next presentation, which will compare the probability of getting the test statistic as high as minus 1.06 with the level of significance of 0.05. So just please do not go away. Please watch my next video. I'll show you how to calculate a probability for obtaining a test statistic as extreme as what we have obtained, and then compare it to the level of significance and make a decision. So thanks for watching. Take care. Please share this video with your friends. If you like this video, please give me a thumbs up. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll be back next time with another interesting way to solve this problem. There's a much quicker way to do this problem, which we will discuss next time. Okay, see you next time. Thanks for watching. Take care. Have a nice day.